You know, every single time you send an email, stream a movie, or just browse a website, you're using a network. But have you ever stopped to wonder how it's all actually laid out? I mean, how do all these gadgets, your computer, your phone, all the servers out there, actually connect and communicate? Is it just some chaotic random mess of wires and signals?
No way. It's not random at all. It's actually a super carefully planned design, a blueprint that dictates how everything is hooked together. And in the networking world, we call this blueprint a topology. You can think of it as a city map for your data.
So, if you want the official textbook definition, a network topology is the geometric layout of how all the links and the nodes, the devices, in a network are related. It's the literal shape of the network, and that shape is what decides all the possible paths your data can take.
All right, let's dive in. We're going to start with the simplest city plan you can imagine. Just one single main road where everything happens. This is what we call the bus topology.
And here it is. As you can see, it's pretty much just one long cable, that's the bus, and it acts like the backbone for the whole network. Every single computer or node just hooks into this main line with a smaller drop line. It's super straightforward, super direct.
So how does this actually work? Well, it's pretty clever. A computer sends a message out onto that main cable, and it travels in both directions. Every other computer on the line sees that message, but only the one with the right address actually opens it. And those little things at the end, the terminators, they are absolutely crucial. They literally absorb the signal so it doesn't just bounce back and create a massive data traffic jam. So what's the deal with the bus topology? Well, it's a classic trade-off. On one hand, it's super cheap and easy to set up because you use less cable, and adding new computers is a piece of cake. But since everyone's sharing one main road, it can get really slow if it's busy. And oh man, trying to figure out what's wrong can be a total nightmare. But the biggest, and I mean biggest risk with this design is its one critical, fatal flaw.
And this shows you exactly what I mean. If that main backbone cable breaks, anywhere, the entire network is dead. Kaput. Every single device is cut off. It's like the main street is closed, and the whole city just grinds to a halt.
Okay, so obviously that's a huge problem. To solve it, designers come up with smarter layouts. So let's check out the next evolution, the ring and star topologies. First up, we've got the ring. Now here, each computer is connected to exactly two others, forming this perfect circle. Data just zips around this loop, always in one direction, hopping from one computer to the next until it gets where it's going. Think of it like a super efficient one-way traffic circle for your data. The beauty of this is that since everything is going one way, you don't get data collisions, which usually means faster speeds. But, and it's a big but, just like the bus, if there's a single break anywhere in that ring, the whole thing comes crashing down.
All right, this leads us to a really popular design, the star topology. Now, instead of connecting to each other in a line or a circle, all the computers connect to one central device, like a hub or a switch. All data has to go through this central point first. It's less of a main street and more like a big central roundabout.
And here's the massive advantage. If one computer or its cable goes down, only that one computer is affected. The rest of the network just keeps on working. The catch, and it's an obvious one, is that the entire network now depends on that one central hub. If that hub dies, everything dies. So what if you need the absolute maximum reliability? What if you need a network that practically cannot fail? Well, for that, you have to build the ultimate city grid. And that's the mesh topology.
Just look at this thing. In a full mesh setup, every single computer has its own dedicated direct connection to every other computer on the network. There are tons of paths between any 2 points, so if one road gets blocked, no big deal. The data just finds another way to get there.
As you can imagine, this design is incredibly tough and lightning fast because of those dedicated lines. A single broken link? Not a problem. But the downside? It is crazy expensive and complicated because of all that cable. So just how much cable are we talking about? Well, to connect just those 6 computers we just saw, you'd need 15 separate cables. Now just try to imagine connecting 50 computers. The cost and the complexity just go through the roof.
Okay, so in the real world, you rarely see just one of these pure designs. Instead, engineers build bigger, more complex digital cities by combining these basic blueprints.
Let's take the tree topology, for instance. It's basically a hierarchy of star networks. You've got a main hub at the top, which connects to other hubs, and those hubs connect out to the computers.
It's a fantastic way to grow a network and still keep everything organized.
And then, of course, you've got hybrid topologies. And they're exactly what they sound like. You just mix and match. You could combine a star network with a bus network, for example, to get the best of both worlds and create a totally custom solution for whatever you need.
So we've looked at all these different network maps. How on earth does an engineer actually pick the right one for the job?
Well, it really all comes down to a balancing act. You've got to think about cost, right? How reliable does it need to be? Is it going to need to grow in the future? How much data needs to flow through it? Each and every topology we've talked about gives a different answer to these questions.
So next time you hop on your Wi-Fi, which by the way is probably a star topology with your router as the central hub, think about the bigger picture. The internet itself is this massive, sprawling, complex hybrid of all these designs. So my question to you is, what other network maps are hiding in plain sight all around you?